Hey ladies and gentlemen, it's Mr. Robeson here. We are taking a look at Unit 4, Section 3, which we're all working with something called binomial probability. So we'll take a look at what makes something become a binomial probability situation, how to find binomial probability, and then we'll take a look at several examples of binomial probability. All right, so first up, binomial probability. It's a situation where there are two options. So there's just two things that can happen. A fixed number of trials, which we'll generally say is n, where we want to find the probability of a fixed number of successes out of those n trials. All right, so there's a lot of things here. It actually breaks down into 4 conditions, which we can remember just by the little acronym that we use, BINS. B, binary. That's the binomial part, meaning that there are 2 outcomes. Sometimes there's more than 2, but we can split it up into 2, where one of them is considered a success and the other one is considered not success, or sometimes we use the word failure. It doesn't mean it's bad, it just means it's not what we're looking for. All right, the I means that the trials are independent of each other. So like what happens the first time does not affect what happens the next time, does not affect what happens the next time. All right, sometimes this condition doesn't work and then we're no longer binomial. All right, N is the number n is the fixed number of trials. So we're going to do things a certain number of times. Like maybe we're going to do things 10 times. We want to know what's the probability of, a certain number of successes out of those 10 times. And S stands for the same probability of success, which we usually denote with the letter P. All right, so an example of something that is binomial. You flip a fair coin 4 times and it should be want to know the probability of getting exactly 3 heads out of those 4 trials. All right, so we're going to check each one of these conditions. So B, yeah, we've got heads and tails, so it is binary. There are 2 things that can happen. I, coin flips are independent. So like if you get the first time you flip a coin, you still have a 50-50 chance of getting tails the next time. That doesn't change. N, do we have a fixed number of trials? Well, yeah, we're going to do it exactly 4 times. So N is 4. And S, does the probability stay the same for success? Yeah, the probability of heads, which is what we're asking about, which we'll say is the letter P, is always going to be 0.5. And we're asking specifically about getting 3 heads here. So our X would be 3 here. Our random variable would be 3. And it is a discrete random variable. All right, so that is binomial. So if we look at this one down here is not binomial. So I'll switch colors. So a bag is filled with half red and half green marbles. What's the probability of selecting 3 red marbles out of 4 random picks if marbles are not replaced once removed? All right, so if we take a look at the B, yeah, we've got red and we've got green. That works. That would be binary. So that condition's okay. Independence. All right, this is where the problem comes in, because once we take out 1 red marble, there's 1 less red marble. So that means the probability of getting a red marble changes. All right, so these trials are not independent. And that is why it's not binomial. All right, n would be fine here. Like the n would be, we're doing 4 choices, so n would be 4. But the S is also a problem. The probability is going to change. All right, each time you take a marble out, the probability of getting either color is going to change because the number of marbles left in the bag are going to change. Sometimes we say that we replace the marbles. Once we take them out, we put them back in. But this says it specifically that they are not replaced once removed. All right, so now we know how to identify something as binomial. How do we find the probability of X successes out of n trials, where the probability of success on any trial is P? Well, there's a formula. I don't really expect you to use this, but that is what the formula looks like. It's called n choose X. This is something called combination. So this is the number of ways it can happen. And when I say it, I mean number of ways we can have X successes out of n trials. P of X is X successes. 1 minus P to the n minus X is the n minus X, what we call failures. All right, so each part of this does have a specific part. All right, the reason why we're not going to probably use this, though, is because it's built into our calculator as something called binomial PDF. And then we just put in the n, the p, and the x, and it gives us the answer. And this is located under second, and then we press the button vars, standing for variables. All right, and that gets us to something called the distribution menu. DISTR is what it looks like. It's in blue writing over the word vars. So we press second, and then we press vars. It brings us to the distribution menu. We arrow down a ways, and it gives us binomial PDF. And if we go down one further, it gives us binomial CDF, which is the probability of X or less successes. So there's two of them. This is exactly X successes. So PDF means exactly X successes. And this means we have X or less. So if we use CDF, it's X or less successes. All right, so let's take a look here. A fair coin is flipped 4 times. What is the probability of getting exactly 3 heads? All right, so we already looked at the coin flip and said that was binomial last time. Our n here is 4. Our x here is, number of successes is 3, exactly 3. And the probability of getting heads, which is our success, p, is always 0.5. So this would be binomial PDF, where n is 4, x is 3, and p is 0.5. So either if you have your app, like one of the calculator apps, some of them you just put in the numbers 4, 3, 0.5 in that order. If you have an actual graphing calculator, it works like this. Second, vars. See how it says DISTR right over that? We arrow down a long ways. We'll learn some of the other things on this menu, by the way. And we want option A, binomial PDF. And we have the number of trials is 4. Our p-value, the probability of heads, is 0.5. And our x value, we're asking specifically about 3 successes. And then we got to paste it, and it's going to look like this. Some of you, it'll just look just like this right from the start. Oops, I switched the order on these two, didn't I? Shucks. Yeah, the p comes first, then the x. So it's the other way around is how it's written. All right, but let's see. What did we get? 0.25. So it's n, then p, then x. So npx, the other way around. All right, the next one. So a fair coin is flipped 10 times. What is the probability of getting 4 or 5 heads? So now, again, we're still flipping coins, so it's still binomial. We've got 10 trials. We want x to be 4 or 5, and our probability of success is still 0.5. So there's a couple ways we can do this. One is just we can find the probability of 4 and the probability of 5 and add them up. So we got n is 10, our p is 0.5, and our x equals 4. And then we can add to it the binomial PDF, where n is 10, p is still 0.5, and x is 5. And we just add them both together. And we can do this all at once if we want to. So second distribution, I'm going to go up. It's faster to get there if I just go up. There it is, binomial PDF. We're doing 10 trials this time, still 50% chance of success. And we're asking about 4 for the first one. Paste. All right, so I can get this answer now if I want, and then just press plus, and it will automatically add this answer to our next thing. So second distribution, or you can do them both separate and then add them up later. Or you could do them all together, actually. And this is 5 now, so this changes. And there's our answer, 0.45. So at least 2 decimal places on these answers is good. So 45% chance. All right, so here's some application problems. So Steph Curry makes 90% of his free throws in a game. He takes 8 free throws. Find each probability. All right, so this is our n. This is our p. All right, there are 2 things that can happen. He can make it or he can miss it. We have a fixed number of trials. Each free throw is independent of each other one. So this is binomial. We want to know about it making exactly 6. So this is binomial PDF, where our n is 8, our p is 0.90, and our x is 6. All right, the next one of him making 7. Well, that's still exactly. So this again would be binomial PDF, where n equals 8, p equals 0.90, and x equals 7. All right, 6 or more. We'd have to do x equals 6, 7, and 8, and then add them all up. All right, well, we've already got 6 and 7. So let's see what are 6 and 7. All right. And for 6, so second distribution, binomial PDF. We're taking 8 total shots. We've got 90% chance of success, so 0.90. And we want to know about making 6 for this first one here. So that's 0.1488, so about 1.15, I guess is what that would round to. All right, for the next one, we got 7. So a real quick way to change this is second, enter. It brings up whatever you had typed in last, and just type back and change that 6 to a 7. 0.38. For this one, we need to find the 8, and then we're going to add it to the other one. So to find the 8, second, enter. I'm just going to change that to an 8. 0.43. So we're going to have 0.43 plus 0.38 plus 0.15. So we're adding up the 8, the 7, and the 6. All right, if we add those up, 0.43 plus 0.38 plus 0.15, 96. So 96% of the time, he should make 6, 7, or 8 free throws out of 8 free throws. That's pretty darn good. All right, what's the probability of him making 5 or less? So we got 2 ways we can do this, actually. So we just found 6 or more. 5 or less would be what we call the complement of that. Right? So these two things have to add up to everything. Either he makes 6 or more, or he makes 5 or less. Those are the only two things that can happen. So since it's complement, we can find the complement probability. Just do 1 minus the 0.96, which gets us, the other 4%, 0.04. Or since it's or less, we can do binomial CDF, where n equals 8, p equals 0.90, and x is less than or equal to 5. All right, so if we type that in, so now this is the other binomial guy here, the CDF, because it's or less. We've got 8 trials, 90% chance of success, and we want to know about 5 or less, so we use 5 there, and press enter. 0.038, which will round to 0.04. All right, so we got 2 different ways we can do that. All right, let's take a look at a couple more examples just for some more practice here. All right, so roughly 25% of the 1,600 students at Oakland High School are seniors. We take a random sample of 50 students from Oakland High School, find each probability. Probability of getting exactly 12. All right, so our n here, so this is binomial. We're asking about exactly, so it is p. Our sample size was 50. Our probability of success is 0.25. And we're asking about exactly 12. All right, now some of you might be thinking, this might not be binomial because once we take one student out, it changes. But there's actually a couple of different things going on here. Since our population size is so big compared to our sample size, it's okay. It doesn't change significantly. So we don't really care because our population size is so big. And that works whenever our population is 10 times more than our sample. And our 10 times our sample would be 500. So that works. But we don't need to know about that for this class. We just need to be able to calculate the probabilities. So we're putting in 50 for our sample size, 0.25 for probability of success, and 12 because we're asking about exactly 12. And we get 0.129, so about 13%. All right, what about 12 or fewer? Well, since it says or fewer, that's the same thing as or less. We're going to do the CDF now instead of the PDF. So our n is 50, our p is 0.25 still, and now x is less than or equal to 12. So we're just using the CDF now instead of the PDF. So second distribution will go up. There it is, option B. So we've got 50, 0.25 probability of success, and 12 is our biggest number. And we get 0.51. So big difference. So that one letter changed from 13% to 51% here. What about more than 12? All right, so whenever they ask more than, think complement. So we've already done less than, 12 or less. More than is the complement, so it's going to be 1 minus that 0.51, which is going to be 0.49. All right, now here's the last one, the tricky one, between 10 and 12 inclusive. So that means we could equal 10, so x would be less than or equal to 20 and greater than or equal to 10. So what we do for things like this, so we do CDF, we start with the 50, everybody, like our sample size. Our P is still the 0.25, and we start with the bigger number, 20. X equals 20. All right, and that would give us all the samples that would be 20 or less. And then we're going to take away something, those guys that are smaller than 10. So we're going to subtract from it the binomial CDF. So we're going to get rid of all the guys that are, let's see, out of 50, 0.25, and we want X to be less than or equal to 9. So less than 10 specifically, because we're including 10, so less than or equal to 9. All right, so if we type that in, and we can do it all at once, so second distribution, binomial CDF. And this is about as tough as it's going to get for these problems, by the way, guys. So we're going to get 20 is our sample size to start. And then we're going to subtract from that. So I'm just going to type minus second distribution, binomial CDF again. And now I'm going to change, I want to subtract 9 or less, because I'm going to want to include 10 still. And that gives me, here's my answer, 0.83. So 83% of these samples that we'd get would have between 10 and 20 seniors. And that's our answer there. All right, so that's really tricky, that last one there, but hopefully as long as we can do problems like the first 3 ones here, we should be good. I might throw in a couple like the fourth just for challenge problems. All right, and that is it for binomial probability for today. Will be another one next time, but that's it for today.